Bismillahir-Rahmanir-Rahim. So, dear students, in today's class, we'll be continuing our previous topic, that is the oxidation by the per-acids or perchloric acids. So, today we'll be doing some important organic transformation. We'll do 3 important organic transformations which are very helpful for solving our organic problems in the competitive exams. So today's problem number 1 will be, we write down, if you have a substrate which is alpha beta unsaturated. So this is your alpha beta unsaturated carbonyl compound. So this is our unsaturated carbonyl compound. Let's say we have some group R here. So this is your carbonyl portion. This is alpha carbon. This is your beta carbon. Fine. So this is alpha beta unsaturated carbonyl compound. Fine. So if we treat this with, or we should say in presence of metachloroperbenzoic acid. Now we know that what metachloroperbenzoic acid can do. It can do 2 things. It can convert an alkene into epoxide, number 1. Number 2, it can convert a carbonyl CO compound. It can convert that carbonyl into ester. Now, ये जो compound है, in this case, we have both the functionalities present. So we have carbonyl also here, we have a double bond also here. So now which compound will be formed, or is it possible that both the compounds will be formed? So now whether epoxide is formed or whether ester is formed, what will happen? So in nutshell there are 2 possibilities. One possibility is that we'll show it like this. So another possibility will show in the form of metachloroperbenzoic acid. So let's say we will make we'll insert oxygen here, so then we should get epoxide. So this is your one reaction which will be created by the metachloroperbenzoic acid. So other possibility is that this carbonyl will be converted into the ester. Fine. So another possibility is this one. That oxygen will get inserted between this and this. That's this carbon and this carbon. So we'll show it like this, oxygen, and then we have that R as normal. So in between this carbon and this R, that is, we have the insertion of oxidation, which is called as the Baeyer-Wilger oxidation. So this is Baeyer-Wilger oxidation. Fine. Now question is that which product will be formed? अब देखिए यहाँ पे what is happening. We know that this epoxidation is preferred when this site is electron rich. Normally alkenes are electron rich sites, fragments, but because of we have here, it is this double bond is in conjugation with this C double bond O, and this C double bond O, because of this strong effect, resonance effect, because of strong electronegative carbon, this pi bond is more towards oxygen, so that results in the conjugation. Fine. So what does that conjugation means? That this alpha beta carbon, it makes it electron deficient. So when the alpha beta carbon is electron deficient, that says that this epoxidation has less chances to occur. Why? Because epoxidation will occur when you have, it's preferred when we have carbon-carbon double bond electron rich. If there are electron donating substituents on this carbon, then we'll get preferred product as epoxide. But in this case, because of the alpha beta, this double bond which is in conjugation with this carbonyl, so because of this conjugation, this carbon becomes, this bond is electron deficient. Now because of the when it's electron deficient, so this epoxide is not formed. So rather this is the route which is preferred. So we should say that in this case, in case of alpha beta unsaturated carbonyl compounds, when we treat them with metachloroperbenzoic acid, the compound, the products formed will be the esters. Fine. So this is our problem number 1 in today's case. इसमें questions आते हैं. Many times questions have been asked in these class type of cases. So you have to remember, just look at whether the alkene is electron rich or not. Okay? Now let's talk about the problem number 2. Problem number 2. Let's have this scheme now. So let's have a scheme. Our substrate, I should like this. Our substrate is cyclohexanone type. Cyclohexanone type. So then we'll treat this with RMGX. MGX, that's the Grignard reagent. So number 1, we have to predict the product here. So what is the product formed? And then the problem continues. It says that you treat this with जो यहाँ पे जो हमें product मिल जाएगा, so that is treated with this TSOH, which is called as the tosyl group. It's para-toluene sulfonic acid basically. Normally it is tosyl chloride, but in this case it is it's in the form of it's not Cl, it's OH based tosyl. So what is the product formed here? But then he says that your final compound is this one. R. So what we need to check out these two compounds which are formed in these two steps. Okay? So we'll start how to solve this problem. So देखिए हमारे पास जो है we have this cyclohexanone. Fine. So we know in RMGX Grignard's reagent, this R is basically this is an organometallic part compound. So this R is negative, magnesium is plus. So negative, they will add on this carbonyl. Okay? So what will happen now? I will solve it here. So add this with RMGX, so R plus. Okay, so R plus will add in this form. This is your oxygen. And here we have, since when the pi bond moves towards this oxygen, this carbon gets plus charge, so negative part will add here. So negative part will add here in the form of R. Now this will get negative charge, so it will take proton from the medium, so it will form OH. This is our step number 1. This is RMGX. Fine. Now I shown this in the shortcut. So in presence of water, so this is forming OH. This oxygen will get converted into OH, and this R dead here. So this is our step number 1. So this is what actually is formed here. Okay. Now, after that we have to treat this compound with para-toluene sulfonic acid. Fine. So para-toluene sulfonic acid, we know that what is that? It's basically you have this benzene. At this position, this is methyl group. This is sulfonic acid. This is your para-toluene sulfonic acid. So what it does that this reagent helps us. Normally it is para-toluene sulfonyl chloride. It helps us in removing the oxygen, okay, from the ring. So now this OH will be converted into the tosyl. Fine. So this H will go with this. It will form water. So this OH and this will go. It will form water. So our product formed will be when you treat this with Tosyl, so you will get this will form OHTS. Fine. So this is OTS, and then this is your R. So this is our product number second. Now how can we convert this into this? It's very simple. As I mentioned earlier, what Tosyl does, it removes this oxygen. So it's used to remove this oxygen so that this gets removed easily because of this Tosyl. Why? Because Tosyl has that extensive conjugation. S double bond or S double bond, the ring here. So this is it gets easily removed, okay? Because it's highly conjugated. So when this gets removed, we develop a positive charge here, and then from the adjacent carbon, we remove that proton. So that generates this para-toluene sulfonic acid back. So what we get finally, we'll get this product. We have a double bond here, we have R group here, that's it. So this is our scheme basically. So at this step number 1, when we treated this cyclohexanone with the RMGX, we'll get this compound. And then when we treat this with the Tosyl, it converts OH into this OTS and makes it a good leaving group. So it takes oxygen away from our original compound. And then finally, because of the plus charge, we'll get a double bond here. So we'll get the finally alkene. That's it. So this is our problem number 2. Now let's discuss one more important problem. Remember, ये जो problems है, this is very very important, particularly जो आपका second paper होता है in the CSIR and also in the GATE second, in the graduate aptitude test, जो second paper होता है, there we have those organic transformation final products we have to predict. So this is very very important. That's why we are doing this extensively in this whole series, comprehensive series for the CSIR-JRF-NET, GATE and others. So we're making this extensive practice. We have problem number 3. Let's say we have this compound. This is an alcohol where we have at this position R and OH at this. So if we treat this with PCC, now this PCC we have discussed this reagent in our classes earlier. It is pyridinium chlorochromate. Okay? So what you get from this, number 1, and the second step. So what you get from here, that is treated with metachloropurbenzoic acid. So why I'm using this metachloropurbenzoic acid on problems, because the last 2 topics हमने discuss किए हैं. One was the epoxidation of alkenes. Second thing जो हमने कल ही discuss किया था, that was the conversion of carbonyl this ketones into esters. So that is actually brought up by that conversion with the help of metachloropurbenzoic acid. So these all problems are related to that metachloropurbenzoic acid. So what is our final product? Okay? So we have to remember, so one thing is important, whenever we have to solve any organic transformation, एक चीज हमारे ध्यान में always होना चाहिए कि we must know the reagent, its function, its stereochemistry, regioselectivity is involved there. We must know, first of all, it's important कि what it does. इसलिए हमने ये organic reagents की series start की है. उसके बाद जो हमारा दूसरा portion, that is the naming reactions. तो naming reactions में हमारे लिए बहुत easy हो जाएगा, because we will be already knowing what the organic reagents will do. So pyridinium chlorochromate, it converts, it's an oxidizing agent, number 1. So what if it is oxidizing agent? Now higher level of OH, the alcohol, that is the carbonyl compound. So it's very simple, it will convert OH into carbonyl. So it will oxidize this OH. So that means the product formed here will be, in this case, so that will be carbonyl, that's it. So oxidize this COH bond into C double bond O, that is the next level of oxidation, which is brought by the pyridinium chlorochromate. Okay, so this is our product number 1. Next is that we have to treat this. It's very simple now. We have to treat this compound with metachloroperbenzoic acid. Metachloroperbenzoic acid converts carbonyls into esters. So you have to insert simply oxygen. Now the question is that whether that oxygen will get inserted on this side or this side. For that we have discussed yesterday that it depends on the migratory aptitude of the groups. हमने discuss किया था yesterday that migratory aptitude follows this order. So that means इस carbonyl के adjacent में जो दो carbons है, this and this, the one which is 3 degree or 2 degree, that it's preferable to add oxygen on that side, to insert oxygen on that side. So on this side we have a carbon where we have two alkyl groups. So this is 2 degree carbon. On this side we have this single carbon. So 2 degree carbon is here, so that is preferred. Okay? So that oxygen will get inserted here. So that means we will write our final product as this is your carbonyl. So we'll get oxygen here. Fine. And then you can show it like this. So we have R here. So I've inserted this oxygen between this and this carbon, because this carbon is attached to this carbonyl. This is 2 degree. So this is the final product formed. Okay. So these are some of the important organic transformation. So always the best technique to solve this organic paper. There are many problems. Almost you get at least 5, 6, 7, 8 like this organic transformation. If you are sure enough to solve the organic transformations, certainly you can qualify your second paper, and that can help you with the help of a good score in the first paper of your CSIR or GATE. You can easily get a good rank. But provided your organic reagents is very strong and your naming reactions, you have good control on this. So with the help of these two portions, you will be in a position to solve your organic transformations around 4, 5, 6 questions easily. Okay? So that's why in this whole series we are doing this continuous organic transformation exercise, organic convergence using different reagents. So this is all about our today's class. So hope you have enjoyed this. So now we have to make one more announcement. Now the next week onwards, maybe in this week, we are starting one more class, because our bioinorganic chemistry series will be completing in this week. So we'll be starting the spectroscopy, simultaneously. So thank you.